So our first notes video is going to be on some important vocabulary that we need to get down before we can move on in the course. Geometry is a language. If you've ever taken a language course before, you know that it takes a lot of work and a lot of studying, and you really have to get the vocabulary words down to be fluent in it. Well, the words that we're going to talk about are the basis of what we need to know so we can move on and learn more about them. And the first few I'm going to talk about are called the undefined terms of geometry. And the reason why they're undefined is because they're kind of abstract and we can't define them in terms of something else, but they are the basis of what all the other figures in geometry are made up of. So first we have point. A point indicates location and it has no size. So even though from person to person we might draw our points different sizes, someone might draw them pretty heavy or dark, it doesn't mean that it's actually a different size. It's just showing a location. Next we have line. A line is a straight path that extends infinitely in two directions without end. It has no thickness, so just like a point had no size, a line has no thickness, and a line contains infinitely many points. So we're kind of talking about the undefined terms in order of which one is contained in the other. So point is the most basic one. Then we have a line, and it contains an infinite amount of points. After line, we have a plane. A plane is a flat surface made up of points that extends infinitely in all directions. A plane also contains lines because lines are just infinite points in a straight path. So a plane, you want to think about a plane as some kind of surface. If you think about your desk or even the ceiling, but it doesn't have an end. It extends on through the quad. It goes all the way to your house. It goes all the way to Australia. It just is going on and on at that surface level. We have planes that go at all different angles throughout the room. They're very abstract. It doesn't always have to be a concrete plane, but we'll reference some concrete planes like a desk or your notebook. So that's a plane. And then we have space, and the space is boundless, three-dimensional set of all points. So you can think of space as outer space. It does not end. We really don't know the end of outer space. We think that space is infinite, and so a space contains planes, it contains lines, it contains points. It's just the set of everything in geometry. So we're going to do all the definitions, and then we'll be opening our foldable to get diagrams on the inside. So if you're a little unsure of what the definition is describing, just wait till we get to the picture to accompany it. So up on the top right, now we have collinear. And a lot of times in geometry, we can break apart the word and dissect what the prefix and the root of the word mean. So we know that like cooperation, means together. And then if you look at the second part of the word, which is linear, that sounds like line. Well, together and line, collinear means points that lie on the same line. They're together on the same line. We also have non-collinear, and I'm actually going to take a second to type this in for you guys. I want to have that example as well. So we also have non-collinear. I want you to add this to the definition. Non-collinear points do not lie on the same line. So if we have 3 points that, we might have 2 on the line and 1 off of the line, those 3 points together will be non-collinear. And then we have coplanar. Just like we broke down collinear, we said co means together, while planar sounds like plane. And you might be able to guess that it means points that lie on the same plane. We're also including lines and any figure that we talk about after this that's contained of points and lines. As long as those figures are on the same plane, then they're coplanar. We could even say triangles are coplanar if they're lying on the same plane. So Now we have figures that are composed of our undefined terms here, and a line segment is not undefined because now our definition will include these undefined terms in it. So a line segment is part of a line that contains two endpoints. So it doesn't go on infinitely in both directions, but it is part of a line and it has endpoints. So we're using those undefined terms now to define everything else. Then we have array. Array is also composed of undefined terms. Array is part of a line that contains one endpoint and goes infinitely in one direction. So the array will have an endpoint, and then in the other direction it'll be going on infinitely, and we'll have that arrow drawn. Okay, so you want to have your foldable opened up. On the inside, we're going to have a diagram, and then we're also going to name all of these figures. Now, there's a very specific way to name each of these, and I want you to make sure that as you take your notes on this, that they're complete so that you can look back at them and know how to name them. This is going to be really important for the first test. The first test is going to be very vocabulary heavy, and making sure you know what all the semantics are for naming these figures. So for a point, we have our diagram right here. Now, a lot of these names will have different symbols that we use to name them. Well, we don't have any symbols to name a point. So up here we have our diagram. I have a point, and then next to it I name it with a capital letter. The only way I can name a point is just by writing out the word point and then the capital letter that's associated with the point. So point A. For our line, there are two different ways we can name a line. The most popular one is this first way, and you name a line by 2 points that are on the line. So point A and point B are the only 2 points we know on this line. If there were more, I could pick whatever 2 points I want. And it also doesn't matter what order you name a line in. So I could name this line AB, or I could also name this line BA. But I write out 2 of the points, and then I draw a line including the arrows. So if you can't see, this is a line with 2 arrows on the end above AB. Another way that you can name a line is with a cursive letter that will be labeled somewhere towards the end of the line. I know that the line doesn't end, but the end of our drawing of the line. And this would be line L. Now in math, we use the cursive L. Well, it actually just needs to be lowercase for the name, but in math we use a cursive L because just drawing a straight stick for L looks like a number 1. So we make sure we use a cursive L in math when we mean the letter L. So again, order doesn't matter when we're naming a line, just any 2 points that are on the line. So then for plane, a plane is named by 3 points, just like a line. The order doesn't matter. So I've named this, and we write out the word plane. There's no symbol that goes above the plane. So I've named this plane ABC because those are 3 letters. But I could also name them in any order. So it could be plane BAC or plane CAB, etc., etc., until we've gone through all the combinations. Another way you can name a plane, similar to the line, is with this letter that's in the corner of the plane, and you can just call that plane M. So I really didn't have a diagram for space, so I just wrote, think of outer space. Outer space is boundless, it contains everything, it contains all life. But in geometry, we're talking more about abstract figures, so it contains all points, lines, planes, any line segments, rays, etc. So then for our collinear, we have points A, B, and C are collinear. I just picked 3 of them that are on the same line. I could have said B, C, and D. Those are also collinear, and any combination of them. And then when we're saying non-collinear, really 2 of them could be on this same line, and I'll explain that a little bit later, but the third one has to be off the line. So for points to be non-collinear, even though B and C are collinear themselves, F is not. And so we think of them as a group, they're non-collinear. So then we have coplanar. We have points L, A, and N are coplanar. They're all on the same plane. And we draw a plane, I kind of skipped over that over here, but we draw a plane like a parallelogram. That's the way we do it in math. It's hard to show a plane kind of being in the air in our three-dimensional space, so we just draw a parallelogram. Next we have line segment. A line segment will be named by its 2 endpoints. So this is line segment CD. The symbol I have over CD is just a straight line. I don't draw the endpoints when I do it for the name. I just draw a line with no arrows. And just like for a line and a plane, order doesn't matter. I could also call this line segment DC. Oops, and we're cutting that off a little bit, but this is the ray. So the ray is one where you do need to name in a specific order. And the ray is named with the endpoint first, and then you need to pick a point that's going in the infinite direction. So I only have one point that's in this direction, but if I had another point right here, say W, I could also name this YW. I just need some point that is between the endpoint and the direction that's going on infinitely. So I cannot name this ZY. It has to be YZ. For the symbol that goes above our name of our ray, we just draw a ray with an endpoint, and we always have it going to the right. Now I know that my ray is kind of also going to the right, but notice I didn't draw it above the name slanted like that, so you don't want to just copy what the picture looks like. You want to use the semantics that I've talked about in this notes video. So make sure that over the name of your ray, the ray that you draw always points to the right. An endpoint must be named first.